Okay, now on to the next video, number 37. Same instructions, and we have f of x equal x to the 1/3 times x plus 8. So this one, you could use your product rule or distribute. And I prefer distributing. You could do whichever. So this would be x to the 4/3 plus 8x to the 1/3. And then take your derivative. So that would be 4/3 x to the 1/3 plus 8/3 x to the negative 2/3. So that would work as your answer. I'm just going to say, or get a common denominator and get three x to the 2/3 on bottom because of the 3 and then the 2/3, and you'd have also factoring out a 4, you have 4 and x plus 2. I prefer this way, but the book has this. Okay, so now we need to get our critical points, and so basically do our graph. Four thirds x to the 1/3 plus 8/3 x to the negative 2/3. Now this is our derivative function. And so that's the derivative, which I'm going to say is blue, and then the original is going to be red. X to the 1/3 times x plus 8. So there's our original one, and have to expand our window just a bit. It's not letting me change that through that way, so I'll just go to the window. Okay, so there. So what I want to do is get my minimum on the red graph between here and here. So that's at -2, comma, approximately -7.56 for your y value. And so we'll have to get an exact number for that. And that would be a local minimum. Okay, local minimum. Let's get our critical points. So looking at the blue graph, the -2 is an x-intercept, 0 is an asymptote, so those would be your critical points. So critical points from the derivative graph at x equal -2, which was an x-intercept, and x equals 0, which is where it was undefined. We kind of talked about where critical points are before in a different lesson, but if you're just looking at the graph, that's how you can look at it. An x-intercept would be a critical point, and an asymptote would be a critical point. So those are your critical points. Then we want to do our number line and put -2 and 0 and test values. So this one, the graph does not stop going left or right. Like it doesn't freeze like in the other one. And so we would have to check the intervals from -infinity to -2, from -2 to 0, from 0 to infinity. Those three. And so once again, we're going to check f prime of -3, f prime of -1, and f prime of 1. So if I go back to my table, my derivative was the blue function in this case, and let's go to the table, settings, independent task, and we need -3, -1, and 1. Again, the blue one in my case was the derivative graph, and so I get a negative, positive, positive. So those were the numbers I got. -0.64, so it's negative there. 1.3 repeat, so that's positive. And 4, which is also positive. So we have that it's increasing. Those were the ones we checked. But because there's two pluses, we're going to have a union sign for this one. So we're going to have decreasing on -infinity, -2, and we're going to have increasing on -2, 0, union 0, infinity, because this was minus and then plus and plus. So because of that, we had to use a union. Okay. And there's no absolute maximum. And the absolute minimum was at x equal -2. And what we got was approximately -7.56. We got that from the graph. So I think that would work, but if we need the exact, I don't know if Math Excel needs the exact or not, But if you need the exact, that's going to be -6 cube root of 2. And so you just have to set the function equal to 0 and figure out how to get that number, just like we did before. Okay, so again, if you need your exact, it'd be this. To get that, you'd say we knew that -2 is our x value for the local min. And so that means in your function you'd put in -2. So we'd say -2 to the 1/3 times -2 plus 8. So this would be negative cube root of 2. Oh, I put my parentheses in the wrong. Well, no, that's right. Sorry. We need negative cube root of 2 times +6. And so that's where you put your negative in front. Like so. Okay, so that's how you do 37. Our next one is 41. And this time you have a different set of instructions. It says identify the function's local extreme values, which are absolute, support your findings. Okay, so f of x equal 2x minus x squared. And your interval is -∞, less than x, less than or equal to 2. So first thing we would do for this is, of course, take your derivative. And so we get 2 minus 2x. Now what we do is set that equal to 0. So you have 2 equal to 2x. And so you have 1 equal x. So that means you have a critical point at x equal 1. And for your number line, we're going to have 1 here. In this problem, because of this less than or equal to, we have a boundary at 2. So it's not going to go to infinity. And so we're going to have to check this side and that side. So check f prime of 0 and f prime of 1.5. So f prime of 0 would be 2 minus 0, which is 2, which is positive. And we would have 2 minus 2 times 1.5. So that's 2 minus 3, which is -1, so negative. So we have a plus and a minus. We also know that f of 1 would be 2 times 1 minus 1 squared. So that's 2 minus 1, which is 1. And for f of 2, we have 2 times 2 minus 2 squared. So that's 4 minus 4, which is 0. So we have our critical point, we have our f primes, and we have our f's. Now the next step would be graph the original and the derivative. So I guess just to keep with the convention I've been doing, I will have the derivative as the blue graph. And the function is the red graph. So the blue graph was linear, and then the red graph would be quadratic. So it looks like that. So 1, 1 is a local max. So local max is 1, 1. So the wording of that is the local max is 1 at x equal 1. And then you also have a local minimum is 0 at x equal 2. Because that's your x-intercept. And that's also your endpoint. So we do have an absolute max is 1 at x equal 1, and we have no absolute minimum. And let's see. The absolute part is B. Everything else was part A. And then for C, they just want the graph. Bang. So you have your graph that looks like that. Okay, there's 41. Our next one's 45. By the way, again, if you need to note this, this is the original graph. Okay, for 45, this one we have f of t equal 12t minus t cubed, and your interval is -3 less than or equal to t less than infinity. So again, think of a bracket -3. Okay, so first step, of course, is take our derivative. So we would get 12 minus 3t squared. Then they want to factor out the 3. So you get 4 minus t squared. And By doing it this way, you would be able to factor this as the difference of two squares. So you're going to have 2 minus t and 2 plus t. So if it's easy like this, go ahead and factor that as the difference of two squares. And that would help you to know your critical points. So t equal 2 and t equal negative 2. So then when you look at your number line, you have to start at negative 3, and that's a bracket. And then you're going to have negative 2, positive 2. So the values we need to check are f prime of something between these, which is negative 2.5, and then check 0, and then something to the right. So now I'm at the step where I graph it. So I do my 12 minus 3x squared and my 12x minus x to the third. So again, just like before, my red one is my original and my blue is my derivative. So go to your table, change independent to ask, and we put in negative 2.5, 0, and 3. Okay, so these are easy numbers to work with. So we go negative plus negative. So those are your derivatives. And critical points. So the next thing is we need just f of negative 3. And so now if I put in negative 3 and go to the original, you get negative 9. So this was from the blue, this was from the red. We also need our negative 2 and our positive 2. So negative 16 and 16. Okay, so those are the important numbers. And then what we do is we see which one is a minimum and which one's a maximum. So now we can probably get rid of the derivative graph. Let's change our window. Okay, so I changed my window to negative 20 to 20, and then I can see this is a minimum, that's a maximum. So go to your minimum from here to here. That gives you negative 2, negative 16. So the way we word that is the local min is -16 at x equal -2. Then the other one, this is a max of 2, 16. And so we say local max is 16 at x equal 2. So next, just think about what would happen at -3. In fact, I'm going to change my Windows setting to -3. So it looks like that, and then this is the part of the graph that we care about, because our original said -3 was our endpoint. So we have this as your absolute maximum. Okay, so all of that was part A. Just put an A right there. And for B, we have an absolute max at, well, they usually put the of first, of 16 at x equal 2, and no absolute min. Because although this is a minimum on our graph, it keeps on going. And so then the last part for this one is to graph it. This is an x-intercept around here. -10. -10, 20. And it basically goes at -2 you have a minimum, down, and then up to where it's +2, and then went through here. So basically something like that. That's what you want. Okay, now we have one more problem. Because we're going to 49. So last problem. And on this one, we have f of x equals square root 25 minus x squared, -5 less than or equal to x less than or equal to 5. So you may know already, but this is a semicircle. Well, I don't need the calculator yet. What we first want to do is say this is 25 minus x squared to the half, and then take our derivative. So we get 1/2 25 minus x squared. Then we lower a number, so we get -1/2, and we take our derivative of the inside and get -2x. So your 2's are going to cancel. And so you end up with negative x over the square root of 25 minus x squared. Okay, then to follow what we've been doing, we made our red one the original and our blue one the derivative. So negative x over the square root 25 minus x squared and square root 25 minus x squared. So there's your semicircle I mentioned earlier, which is above, and it's basically going from negative 5 to 5 because that's your endpoints. So what we need to remember is we're going to go from negative 5 to 5. In fact, I'm going to go ahead and do part C first, since it's so easy. I know we need to still do part A and part B, but there's part C, because it's just so easy. Okay, so what we want to do is find out our critical points, and so that'd be at negative 5, 0 where it's a maximum, and at 5. So we have critical points at x equal plus and minus 5 and x equals 0. So then for your number line, we're going to have negative 5, which is really a bracket. We're going to have 0. We're going to have 5, which is really a bracket. So we want to try f prime of, let's just make it easy. Try negative 1 and 1. Okay, so since we're doing the primes, those are blue. And so when I do control table and change this to settings, independent task, negative 1 is 0.2, so positive, and then this is negative. So you go plus and minus. So we could have chosen negative 2.5 or whatever. I chose negative 1. So just to be simple. Okay, now we also need to try our other values. For the red one, we need f of 0, f of negative 5, and f of 5. So 0, negative 5, and 5. So for the red graph, we get 5, 0, 0. Okay, so now we interpret that and so we have a local minimum of 0 at x equal plus and minus 5. A local minimum of 0 at x equal plus and minus 5. And we have a local maximum of 5 at x equals 0. Okay. And then we need part B. Based on the graph, we have the same exact things. Absolute max is 5 at x equals 0, and absolute min is 0 at x equal plus and minus 5. And again, don't forget to do C, which is there. Okay, so that ends up all of the lesson.